Hi everybody. Today we're going to look at measurements and calculations in science and how to use numbers. We have 6 main topics to look at, including units of measurement, metric system prefixes, conversions on the factor label method, and then scientific notation, error, and significant figures. Today we're going to take a look at these first 3 topics: units of measurement, metric system prefixes, and conversions. We're going to use the System International, or the metric system in science, almost exclusively. And I'd like you to know the base units, the basic units, the most fundamental units, the common ones, that are used for length, mass, time, and temperature. So here they are: length, we use meters; mass, we use grams, even though technically it's supposed to be kilograms. We use grams for our base unit. It makes our math easier. For time, we use seconds, and for temperature, we use Kelvin, or often, we use Celsius. Okay, so make sure you write those down and know them, memorize them, take a look at them a few times, but you probably know them somewhat at least already. There are also some derived units that you should know. Derived units, that means we have to derive them or calculate them, such as area, length times width, right? So the base unit for area in the metric system is square meters. The base unit for volume, well, iron this thing, is supposed to be cubic meters, but again, we're going to sort of break the rules a little bit. We use liters. We use liters a lot. And for density, another thing that we calculate quite regularly, it's supposed to be kilograms per cubic meter, but we almost always use grams per cubic centimeter for liquid solutions anyway in chemistry. So make sure you take a look at these two. Maybe you want to put them on flashcards or figure out some way to memorize these. Okay, so SI prefixes. Would you please be so kind as to write this, everything that you see here, write that all down, everything that you see in yellow, all the way from nano to giga. All right, so nano is like pennies. They're very, very tiny. Whatever a nano, nanograms, nanometers, nanoliters, a very tiny amount. So you need a lot of them. Small units, you need a lot of them. Up here at this end, they're kind of like $100 bills. They're big units, so you don't need very many of them. The next thing that you need to really focus on is the decimal. Can you see the decimal right there? All right. The base units go right here, and those are like grams or liters or meters, depending on what we're talking about. Those are all base units, and the decimal is here. But all of these other prefixes have decimals as well, even the ones that don't have names. For example, this is deci, and if you don't know what the little d stands for, you can look down here. The little d is deci, look down below. So deci's decimal is right there. Centi's decimal place is right there, just on the bottom right corner. There's milli's spot. Now right here, this space, I don't think there's a name for this. If there is, I don't recall ever hearing it, but it does exist. You could call it whatever you want to if you really want to have a name for it, but it's a place that does exist, and it does have a decimal place, and it's right there. Here's the next one. The next one, this funny looking U, it's actually the Greek letter mu, and that means micro. And over here we have another space, another space. They exist, but they don't have names. And then here's nano. There's 2 ways to convert within the metric system, and that is by moving the decimal, and the other way is using the factor label method. So we'll look at move the decimal place first. You've probably run into this in your career. The advantage is moving the decimal is quick, but the disadvantage, and this is a big one, we don't really want to make mistakes in chemistry because they can be dangerous. The disadvantage is it's easy to make mistakes. Here's how you do this, and for easy calculations, this works great. How many centimeters are there in 25 meters? Well, what you do is you figure out where the decimal is for 25, and it's right there. There's the decimal, 25 meters, and we want to change meters into centimeters. So you need to look up at your prefix table here, and you see that we have to move 2 decimal places. 1, 2. Now the number that has two zeros is 100. So it's either the case that there are 100 centimeters in 1 meter or 100 meters in 1 centimeter. How does that work? Well, at this point, you have to think back to the pennies and the $100 bills. Well, we want to get centimeters, and centimeters are small, so we know we need a lot of them. So we're going to move the decimal either to the right or to the left some way so that we end up with a large number. Well, if we move to the left 2 places, we get 0.25 centimeters, and that doesn't seem right because centimeters is a small unit. We need a lot of them. So instead, we should have moved the decimal to the right. And that gives us the number 2500. 2,500 centimeters is the same as 1 meter, which makes sense. Let's try a couple more problems. 5.8 milligrams is how many grams? 5.8. So we're going to go from up top here, from milli to our base unit, which is grams, and that is 1 decimal place, 2 decimal places, 3 decimal places. Move it 3 places. Let's see, which makes sense, moving to the right or to the left? Well, grams is bigger, a bigger unit, so we need less of them. So let's move it 3 decimals to the left. And our answer is 0.0058. Conversion factors are equalities. So here are 4 different ways to write the equality, which is 4 quarters being the same as $1. We can say 4 quarters is the same as $1. We can say $1 is the same as 4 quarters. We can say that 1 quarter is $0.25, or we can say that $0.25 is 1 quarter. All of those are true, and they're all equal. They're equalities, and we can use those as we run a problem. So what we were doing just before, we had our decimal, and we said we had to move it so many places. But in this case, it's not going to work because this is not base 10. So we're going to have to use the factor label method. So what we do is we say, all right, we have $225. I want to figure out how many quarters that is. So I want to get rid of the dollar sign, and I want to get quarters. If you'll allow me to just write QTR, that'd be great. So we just said 4 quarters is $1. So all you have to do is take 225, multiply times 4, divide by 1, even though dividing by 1 doesn't really do too much for you, but sometimes there will be a number other than 1 here, so it's good for them to do that, at least when you're starting. And then dollars will cancel. So let's take a look what this would be like on our calculator. Oops. So we take 225 and we multiply by what's on top times 4 and hit enter, and now we divide by what's on the bottom right here, which is 1, and hit enter, and the answer is 900. So over here we write down there are 900 quarters in $225. That was easy, wasn't it? Let's try some more problems. All right, now this is called dimensional analysis, or actually it's called the factor label method is the method that we're using. And what's awesome about this is it's fail-proof. You almost can't make a mistake. The disadvantage is it might take just a little bit longer, and sometimes people don't like being all neat and tidy. You just want to get your work done. But this way everything will be correct when you are done. All right, let's try the next problem here. All right, is 25 meters is how many centimeters? Well, meters is on the top here. It's in the numerator, even though it doesn't say it. It's really 25 over 1. So I want to get rid of meters, and I can do that by multiplying by meters on the bottom on this side. And what I want to get is centimeters, cm. Oops. All right, well, there are 100 centimeters, and I know this by looking back at that yellow table that we used before. There are 100 centimeters in a meter. It's just like there's 100 cents in a dollar. Meters will cancel with meters, and let's do our math. 25 times 100 divide by 1. You can check this on your calculator if you want to, but I'm pretty sure it's 2,500 centimeters. Let's try a tougher problem, shall we? Boom. All right, 99 kiloliters is how many hectoliters? Kilos to hectas. Oof, I'm not too sure how that works. Oh, here it is, right down here on the bottom. Kilos to, it's only one place away. That's 10. So what you do is write down what you know. In this case, we know 99 KL. And way over on the right, you write down equals HL. Now, this problem is going to only take one step, but in the future, we're going to need more space. There might be 2 or 3 more conversion factors that we need. We don't need those today, so we won't use that. We want to get rid of KL. We want to get HL. All right, so let's look back down here now. This is the side that had the $100 bills on over here, right? And so they're bigger, and you need less of them. So you need hecto, therefore, is smaller, and you need more of them, and it's only 1 decimal away, so 10. You need 10 of these. 10 HLs is equal to 1 KL. 10 HLs. 10 is equal to 1. And kiloliters cancel with kiloliters. And 99 times 10 divided by 1 is, I think it's 990. Another problem. Boom. Decagrams to decigrams. I think I'll just skip that one because I want to move on to a tougher problem. And the tougher problem I'd like to move on to is this. It's a 2-step problem, the dreaded 2-stepper. All right. 8.7 millimeters is how many miles? Now I'm pretty sure it's a small amount because millimeters, are very tiny. So 8 of them might be like this. That's not very many miles, but we can still calculate it. So you write down what you know, 8.7 m, and then way over on the right you write down what you want to get, miles. I'm going to write down mi for miles. Now, can I do this in 1 step, or do I need 2 steps or 3 steps? Well, it's a 2-stepper. But what would we do? We think, I could go from millimeters to meters, and I can go even all the way to kilometers. Oh, 6 decimal places away. And then I'll know kilometers or kilometers. And then this conversion tells me how many miles it is. So our first conversion factor, I will get rid of millimeters, and I will get km. And I did not leave myself enough space here, did I? So from milli to kilo, it is 6 decimal places, 2, 3, 4, 5, 6. What's a number that has 6 zeros, a 1 and 6 zeros behind it? It's a million. I'm going to have to write it at an angle here. 1, 2, 3, 1, 2, 3. A million millimeters is 1 kilometer. Now that I have kilometers, I can go to miles. So I need another conversion factor here. Get rid of km and get miles. And 0.62 miles, 0.62 miles is the same as 1 kilometer. Millimeters will cancel with millimeters. Kilometers will cancel with kilometers. And the only thing that survives here is miles. So let's do our math. All right, here we go. 8.7. 8.7 times the top times 1. Hit enter. Divide by the bottom. 1 million. 1, 2, 3. 1, 2, 3. Hit enter. Multiply by the top. 0.62. Hit enter. Divide by the bottom, which is 1. Hit enter, and there we go. The answer is 0.00000500539. 0.000. Let's see. Oops. Okay. I hope I remember this. 0.0034553. 9, I think it was. Yep, we predicted this at the beginning. That would not be very many miles. That's not very many miles. All right, so that is today's lesson. We've looked at several things. We've looked at the base units. We looked at prefixes. We looked at the move the decimal method, and finally the conversion factor label method. All these are ways that we deal with